Okay, today we want to write a program using the mouse for Marty PC. And in order to use the mouse on Marty PC, you have to capture it. And that's Control F10. Now, to begin writing our code. Now, you could choose your favorite emulator. I'm going to use something simple here. Let's see, TED 3. This is based off of one that was published in PC Magazine a few decades ago, and it was modified and included on, I think it was a shareware disk I had found. Anyway, it's available on the internet. It's not too difficult to find, and let's get started. First of all, we're going to make a COM file. What is a COM file? Well, without getting too detailed, whenever a program is executed in MS-DOS, if it's a COM file, the program is assigned a program segment prefix, and then the program is loaded directly into memory and simply executed. There is no file header. So whatever work you do, it has to be precise and there's really no room for error. That's true for assembly language regardless, but at least with exe files, there's a file header to kind of help you out a little bit. But anyway, so we're just going to make a COM file. So there's no need for a stack, but we will need data and code. So I'm going to use a start label and we'll end start. The reason is because sometimes I forget to include this. Anyway, now we're going to write the code to check the mouse driver to see if a mouse driver or a mouse is loaded, and to do that is very easy. Well, actually, I think it might be best I do it this way. If I load 0 into the accumulator and do a dispatch to the mouse driver, this routine, and this is really all it is, think of it as check mouse driver, and we're going to compare AX to 0. If it's 0, no mouse had been loaded, and so we need to handle that process. So no mouse, and we'll get back to this in a second. So what's going on here? So this is mouse service. You can think of it as a mouse service dispatch. And the function, and this is the function for the dispatch. We're going to compare the accumulator with 0 and jump to 0 if it is 0. So that's what's going on here. If it's not 0, it'll continue, but we'll handle that in just a sec here. We need to tell the user at this point that, actually, we're going to do it this way, offset, and we're going to do message 1. There we go. And what is this? This is function 9 for the DOS dispatch. So this is what they call a DOS service dispatch. And what that is, MS-DOS has built-in services that you can use. they did a lot of work themselves, so you can take advantage of those services that they had already written. And this is function 9, or print string, or print DOS string. And DX, or the data register, will contain the offset to the message. So location, we'll just say location of message, okay, or string. Location of string, that would probably be better put, okay. And after that, since it's a COM file, we can simply return control to MS-DOS with a simple ret. Another way to do this, or healthier way to do this, if you didn't mess with your stack, it's best to probably do the DOS service dispatch. DOS dispatch to end program. So that's what interrupt 20 does. It's straightforward. It's all it does. It's similar to return, but it handles a little bit better than a simple return. So we'll just leave it at that. Now, the no mouse routine has been done. Now we got to display some graphics, right? I think it'd probably be better to show CGA. We're going to do 4, and this is for video mode 4. This is a BIOS, by the way, a BIOS service dispatch. And function 4, CGA mode. Pretty simple. And by the way, when I first started the program, I could initialize the mouse driver with the same function as before, but what I was doing here, this essentially makes the accumulator 0, and it takes fewer bytes. That's all it is. And then, of course, your mouse service dispatch. Now, you don't have to keep doing this mouse service. You can just simplify it to say mouse service. And what this is going to do in CGA mode is it'll center the cursor to the default position. That's ideal for when we do the next step after displaying the text. Because the DOS supports string printing, it'll work on CGA as well. So we'll do offset, and let's see, we'll do message 2. And that's the string we're printing. Here we go. And before I get too involved, let me set up message 1 and message 2. So data will contain message 1. There is no mouse driver or mouse loaded. Mouse found. There we go. And then do CRLF and all that good stuff here. What is though this? Well, these constants are because MS-DOS for some reason requires a carriage return and a line feed after each string if I wanted to have a new line. Otherwise, it'll just terminate at that string and it won't do a new line afterward. Anyway, and message 2, click mouse button. And we'll end the string there. We don't need to worry about carriage return line feed here. Anyway, so far so good. Now that we displayed click mouse to continue, we want to turn on the mouse cursor, and that's function 1 of the mouse dispatch. So we can say, to make it easier for you to see, let's say show cursor. Pretty straightforward. And that's what all this does. It's real simple. And this is why programming the mouse in assembly language is really easy. Now that we show the cursor, now we got to test the mouse. So we got to do check mouse. In this routine, we're going to do check mouse state. And that's function 3. And of course, call your mouse service. And we're going to compare VX with 0. If it's 0, that means no mouse button has been pressed yet. So we're going to go ahead and check mouse. And it's going to keep looping until a mouse button has been pressed. This is why it's important to check to see if the mouse driver has been installed. Otherwise, this will be caught in a forever loop, and you don't want that. So once the mouse button has been pressed, that's it. We're done. So before we finish, we'll have to hide cursor, and that's simple. That's function 2. And then we'll turn on text mode. That's AX3 int 10H. And this, of course, a BIOS service to show text mode again. It also clears the screen, so you don't have to worry about that. And of course, end the program. I could even do this end program. There we go. That's it. That's pretty simple. We're going to call this mtest.asm. I wrote a batch routine here to use the assembler. So we're going to set that up. So we're going to do tasm mtest.asm. Looks like there are no errors. T-link mtest obj. And this is the trick to make the compile. Invalid entry point. See, this is why I love editors. The entry point, we need that before the code starts. So we got to do an org 100h. And then now we can assemble this properly. And now we have a working compile. And we'll do mtest. And there it is. A working compile. Click the mouse key. Oh, there's one more thing, and this is kind of annoying. If I were to hit the mouse button, it's just fine, it ends. But watch this. If I hit like the keyboard and then click the mouse key, you see it carried over some of the key presses. What if you want to clear that? Well, you can, and the way you do this is the DOS service to clear the keyboard buffer. And you want to do that before the end of the program. There it is. So before the program ends, I want to clear key buffer. And you do that simply by doing this. And there's a reason for me formatting it this way, because we expect nothing, right? So it's just good practice to program it this way. And that's also a DOS service to clear the keyboard buffer. So we're going to save this and then reassemble this, and then finally, there we go. And test. Now if I type in keys, it's not going to leave behind any of those key presses. So as you can see, this is a COM file, and if you want to make an exe, go ahead, you can make an exe file, but you can see using debug just how small and compact this program is. See, straight to the point. That's it. It's easy. Anyway, so I'm gonna go ahead and quit this and end this video here, and I hope this helps your research into retro computing.